All right. Hello, everyone. We are continuing on. Today we are looking at lessons 19 and 20, some new and review terminology that we need to go over. So again, hopefully these lessons, as we go over the new concepts, 5-10 minutes at most. I'm going to go ahead and turn off my camera so I'm not distracting myself. Share my screen, pop up and have probably the share of the share of the share of the share. Yeah, so we'll go ahead and get over here, pull up our textbook. So we're on page 99. We're looking at lesson 19. So factors and prime numbers. So again, factors are different numbers that go into numbers. Sometimes if they're a prime number, they only have themselves and 1. So 3, for example, 3 divided by 1 is 3. 1 and 3 go into 3, and that's it as far as our whole numbers. Then we look at a number like 12. Well, 12 has 12 and 1, 6 and 2, 3 and 4. So all of those would be factors. So if it's just 1 in itself, it's a prime number. If it's more than just 1 in itself, then it would be a composite number. So some numbers have no factors besides 1 in itself, and some have multiple factors that go into it. So the example here, 2 times 3 is 6, 1 times 6 is 6. So both 1 and 6 are factors, along with 2 and 3 of 6. So 6 would not be a prime number, it would be a composite number. The factors of a given number are the whole number that divide the given number without a remainder. So again, obviously there's mixed numbers and decimal numbers that would go into it. We're talking about whole numbers, so there's no remainders. There's no fractions left over. Okay. And then we can draw out 6. We can do a 1 by 6 rectangle, or we can do a 2 by 3 rectangle and have 6 boxes in both of those as well. So that tells us that we have a factor. So if we look at 10, well, we know 1 times 10 is 10, 2 times 5 is also 10, so those would be our factors of 10. And again, if you're more of a visual student and drawing it out as a 2 by 5 and a 1 by 10 kind of helps you visually to see it. As we get into some larger numbers, that may be more time consuming, but if for right now, it kind of helps you to see that it is a factor and that it evenly goes into 10, then by all means do it. 12 was an example that we used earlier. It has 1, 2, 3, 4, 6, and 12 that go into it. So it's definitely not a prime number. It is a composite number. So here's a list of the first 10 counting numbers and their factors. Which of the numbers have exactly 2? So 1 only really has 1 in itself, but it is 1, so that one's kind of unique. We don't call it a composite number, but we also don't call it a prime number. So 2, 1 times 2, that's it. So that's a prime number. Same with 3. 4, we have 1 and 4, but also 2 times 2, so 2 is a factor. So it has more than 2 factors, so it's a composite number. 5 prime, 6 composite, 7 prime, 8 composite, 9 composite, and 10 composite. So, those aren't the only prime numbers, but those are the lowest examples that we have closest to 0 that are prime numbers. 2, 3, 5, and 7. So 1 is kind of the unique one that only has 1 factor, so it's kind of a rule breaker. It's neither prime nor composite. The next 4 prime numbers, well, again, you may start to get these memorized down, or you can just kind of go through the rules of, we know if it ends in 5 or 0, 5 goes into it. If it add up all the numbers and it's divisible by 3, 3 goes into it. If it's even, 2 goes into it. So obviously any even number besides 2 would not be a prime number. So the next ones, well, 9, we said is composite. 10, 11 and 1 is all that goes into it. So there's a prime number. 12, no. 13, Got 13 and 1 is all that goes into it. 14, no, 15, 5 and 3, 16, 4 and 4, 8 and 2, 17. Well, that's a prime number. It's only 17 and 1. 18, 9 and 2, 6 and 3, 19, 19 and 1, and then 20, obviously 5 and 4, 10 and 2, 20 and 1. Those all go into it. So it's just kind of going through your numbers and then thinking either through the rules we've talked about or just mentally checking, are there any of our numbers that go into it? If so, then it is not a prime number. Okay. So examples 11, 13, 15, and 17, and then 19, or sorry, 15 is not. 11, 13, 17, and 19 would be the next four. Okay, and there's your practice set. You can look over those, but we'll go over those in class, do some examples of each. So just get familiar with what is a prime number and why is it prime. Okay, then we're looking at lesson 20, greatest common factor. So we just talked earlier about what a factor is of something. If, more than one in itself go into it, it's a composite number, so it has multiple factors, not just two, not just itself and one. And if we want to find the greatest common factor, that means we're looking at more than one number and we're trying to find. So if we're looking at 8 and 12, so 8 and 12, we know, well, 2 times 4 is 8, 8 times 1, okay, and you can do this in any order you want. 12, we know 6 and 2, 4 and 3, 12 and 1. So 1 is a common factor of any number, but that doesn't really help us out. So 8 doesn't go in here, so 8's not going to work. 12, but 12 obviously doesn't go into 8. 3 doesn't go into 8. 2 goes into both, but then 4 also goes into both. 6 doesn't go into 8. So we have 2 and 4, but since we're talking about greatest common factor, 2 is a common factor, but 4 is greater. So GCF, the greatest common factor, would be 4. So that's what we put in for our greatest common factor. Or more commonly, we'll see this for short. Okay, we're still up and running. Sorry, I just keep getting kicked off of my own recording, so I'm making sure we're still good and I'm not talking to the wall. Okay, 12 and 18, same thing. We list out all the factors. That's the easiest way to do it. You can do your tree diagram if you 6 and 2, 3 and 4, however you want to do it, just list them out. Again, as long as you have all of the factors, and then just compare the 2 or 3 or 4, however many numbers, to find the highest number that they all have in common as a factor, then you will find the greatest common factor. So in this case, 1, 2, 3, 4, and 6 for 12, which we just did, and then 18, 1, 2, 3, 6, and 9. So 6 is the highest number that they both have in common. That would be the greatest common factor. Okay. Example 2, 6, 9, and 15. It's not just necessarily two numbers. We can find the greatest common factor for 3, 4, 5, however many numbers. So we just list them all out. 1, 2, 3, 6. We know 9 and 15 are odd numbers, so 2 is not going to go into them. 1, 3, 9, 1, 3, 5, and 15. So we have 1, 1, 1. That doesn't really help us. We have 2, but not here. We have 3, 3, 3, 6, but no 6, 9. No one here, 15, and obviously only here. So 3 and 1 are the only ones that appear in all of them. 3 is greater than 1, so 3 is the greatest common factor. And this will help us when we get into really high numbers and simplifying fractions and things. If you can think of greatest common factor, we can factor out those things and simplify fractions a lot faster. And then this practice set, we will go over that as a class. So if you want to take a look at it, that's fine, but we'll go over some of those in class as a group. That is it, and see you guys soon.